For extension 4.4, we're going to be solving linear equations by graphing. So this is going to apply when we have a situation that looks like this, which in the past we may have solved algebraically, where basically we have a linear equation here and it's equal to another linear equation. We have them set equal to each other from the get-go. So one way that I can solve this is just by graphing this equation, and seeing where they overlap. So, for example, this is what you're going to see. X plus 3 equals 1/2 x plus 1. Linear equation, they're equal to each other. You'll notice there aren't any y's here, so I don't have to worry about having a y component to my answer. I'm just looking for what x has to be equal for these two linear equations to be equal. I'm going to start this off. I'm going to graph x plus 3. It's 1, 2, 3. And my slope is 1. So up 1 over 1, up 1 over 1. I can go backwards. There's a line with the slope of 1. And I'm going to very carefully graph this. Remember, the more accurate your graphs are, the better off you're going to be when you're finding the solution. So there's my first line. And then I'm going to graph this other half, 1/2 x plus 1. So I start at 1, and I go up 1 over 2, and I go back 1. And I can already see where that intersection point is going to be. So I graph this line. And I can see that these two lines are going to intersect where x equals -1, 2, 3, x equals -4. So my solution is x equals -4. And that's all there is to it. You are going to have some real life applications where you have to come up with the equation first. But you know, that's really not any different, and you can even look at the equation, or I'm sorry, look at the example in your book to look at that, but this is all we're doing. And again, my answer just has an x because I didn't start with any y's. I only have an x in this equation here, so my answer is just x equals -4. So you will have a lot of time to work on not very many homework problems, so good luck.